Okay, now we're going to move on to solving absolute value equations. And the method we're going to look at today is graphing. Now, if you're following along in the book, this is the first part of section 4.4. Okay, so what we're going to do is solve some sort of an absolute value equation. Now, first of all, what's an absolute value equation? Well, I'll give you an example. It would be something like this. 0 equals the absolute value of x minus 2. It's basically an equation that has an absolute value sign used in it. And so what we're trying to do is figure out, well, what values of x make this equation true? Now, the graphing method works as follows. What we're going to do is we're going to graph a related function to this. In other words, I'm going to rewrite this as y equals the absolute value of x minus 2. And if I graph this, how is that going to help us find the solution? Well, to show you, let me just get some points in a table of values here. Okay, so say I was going to graph this, and I thought, well, okay, let's get started. Now, where's the vertex in this? Well, the vertex is wherever the absolute value of x, this stuff here, has to turn to 0. And I know that happens when x is 0. If I plug 0 into this, I'm going to get the absolute value of 0 minus 2. So that's just going to be 0 minus 2, so that's negative 2. So that's where my vertex is. And now I'm going to make a point on the left side and a point on the right side of my vertex. So let's plug in negative 1. So I think we got enough room here. If we plugged in negative 1, we would have absolute value of negative 1 minus 2, so that would become positive 1 minus 2, and we would get negative 1 as a y value. And you can see the same thing is going to be true if I plugged in positive 1. It's already positive, and then I'd go minus 2, so I'd also get minus 1. So how is this actually going to help me solve this specific equation over here? Well, this equation is related to this function where it has y equals. And what you're basically saying is we want to figure out when y is specifically 0, what are the x's? Okay? In other words, what I'm looking over here in my table is I'm trying to figure out when the y value is 0, what are the x's? And if I can do that from a graph, then I have solved this absolute value equation. Okay, so that is the goal that we have here. Okay, so let me just clear off the page, and I'm assuming you've got your absolute value stuff, your tables written down. I'm going to clear the page, put the grid up, and I'm going to get the graph. So there's our grid, and let's plot those points. So we had the point, the vertex at 0, negative 2. And then we had the point negative 1, negative 1. And we have the point positive 1, negative 1. So there's our little V shape. Let's draw some lines here and see if we can get the actual graph. So there's one of the lines, the other line going off this way. Okay, so there's our graph. And specifically what we were looking for, and I'll just refresh your memory, to solve this equation, absolute value of x minus 2, when does it equal 0? That's like saying we want a y value to be 0 in the related function. So in our table, or maybe I'll just write the specific points, we're looking for any points where the y value is 0. Are there any such points? Well, here's one. There's one right there. And that is the point when x is negative 2, there is a y value of 0. There's also another point over here when x is positive 2. Okay, so these 2 points, which by the way are called the x-intercepts. It's where they cross on the x-axis. So we have our x-intercepts. That's when y is 0, and specifically x is negative 2 and 2. So those are the solutions to this equation up here. Okay, so this guy up here, okay, that equation we have just solved by graphing. The solutions are x can be plus or minus 2. Okay. Now let me just clear this page, and I'm just going to write up what the method here is. Okay. So you're given some sort of some sort of absolute value equation. So what is the method we use to solve? Well, the first thing you've got to do is you have to make sure that you have 0 equals, okay, whatever else you have on the right side. Really, really important that that is 0. So you have to make sure if you've got stuff on both sides that at least one side has 0 equals. And then you graph the related function. So you end up graphing y equals. So y replaces the 0. Okay, so this is now replaced with a y, and then you graph whatever equation you happen to have here. And then you identify your y-intercepts. Sorry, your x-intercepts. So identify the x-intercepts. Those are your solutions. Okay, so this is the method. These are the 3 steps that you use when you solve by graphing. So let's clear this page, and we'll do one more example here. Let's get the grid up there. Okay, so we can just, as we develop points, we can plot them right away. So we're going to solve the following. We're going to try to solve 4 equals the absolute value of x minus 1, and that's all there is to it. Okay, so in order to solve this, step number 1 is I don't like this 4 sitting there on the left side. So what I'm going to do is I'm going to move that 4 to the right side. So I'm going to go absolute value of x minus 1 minus 4. So I just moved it over. Now I can relate the y equals. This is my related function, and I am going to graph this related function. And I just need some points to do that. So a table of values would be helpful. Okay. And I don't really need too many important points here. I want to use the vertex. And the vertex, remember, is wherever this x minus 1, wherever that turns to 0, that's the x-coordinate of your vertex. So I know that that's 1. And what I'm going to do is I'm going to go 1 point to the left and 1 point to the right. So these are all I really need to go by here. So if I plug the 1 in, 1 minus 1 is 0. So the absolute value of 0 is 0, and 0 minus 4 is negative 4. So there's my vertex. It's at 1, and then 1, 2, 3, 4. So it's down here. Then I've got to plug in 0. So I go 0 minus 1. I get negative 1. But I absolute value that, so it becomes positive 1. And positive 1 take away 4 is minus 3. Now the exact same thing is going to happen when I plug in that positive 2. So when I plug in the 2, I get 2 minus 1 is 1. 1 take away 4 is negative 3 as well. Okay, so here's roughly my framework for my graph. So let's just change this to the lines, and we'll graph the rest of it here. Okay. There's one of the lines. Okay. All right. It's yeah. Sometimes your graph isn't going to be as accurate as you would like. So I'm going to show you a little way to analyze this thing on your graph for greater accuracy. I would like to figure out now my solutions are going to be when y is 0. Okay. So specifically when y has the value of 0, what are the x's that do that? These are the x-intercepts. Now this looks to be 1, 2, 3, 4, 5, but what if my graph is off a little bit? So I'm going to show you a little safe way to do that. I'm just going to go a note here that every time I go 1 to the right, I go up 1. So 1 over goes up 1. And I'm just going to kind of walk my way along here and just make sure I'm in the right spot. Okay, so I'm just kind of walking my way along. And I go, yes, that's exactly where I want to be. From here, I moved over 1, 2, 3, 4 steps. So from 1, 4 steps over, this is in fact 5. So that's one of my solutions. Now I'm going to use the same method over on this side. So 1 to the left and up 1, 1 to the left and up 1. You can see my grid isn't perfect because it sort of starts to waver a little bit at this point here. So what I do know is if I go 1 to the left and up 1, actually the answer is this number right here, even though my line didn't exactly go zinging through there. I can see it is -3. And of course, the other thing I can always do is if I don't really trust my work, there's nothing to stop me by plugging those x values in to the original equation and making sure that the left side equals the right side. So these are my 2 solutions using the graphing method. Okay, next time we're going to look at an algebraic approach.